Hi guys, and welcome to today's video on area of a circle. Really good to see you. My name is Darren, otherwise known as MaffsGuru. Now, this is building on a series of videos we're doing for real number. Basically, the previous lesson was about circumference of circles. So if you've already watched that video, you are going to be a gun with radius and diameter, which is pretty much all we need for the area of a circle. The circumference, good to know, but not actually needed in this particular video. I'm going to take a look through as we go how you find the area of the circle, the different ways of writing the formula, approximations of pi. Got some great examples for you. Stay tuned. Now, if you haven't already done so, can you click the little doohickey in the corner? That basically just lets me know that you're watching. Never going to be rich and never going to be famous. But for every person who clicks that button, it just sends a signal to me to say, hey dude, I'm watching. I'm one of your 8 subscribers and I would be greatly appreciative if you could. And if you want to follow my link above to maffsguru.com, there is all the videos easily found, searchable by textbook, by chapter, and with downloadable notes for you to put in your summary book and your exercise book if you want to. Well, the only way I can be any more helpful today is do your homework. I'm not going to do that. Okay, so area of a circle. If you haven't watched the previous video, here's a quick recap. We knew that the circumference was all the way around the edge, and as I've just said there, probably not going to need that in any way, shape or form, but what we are going to need is maybe the diameter and the radius. Now, what is a diameter? A diameter is nothing more than the distance from one side of a circle to the other passing through the center. Now, it has to pass through the center, otherwise it's known as a chord. Pring! No, not that type of chord. Otherwise, there is a radius which goes from the center to an edge. And it doesn't matter which edge, as long as it starts from the center, then it goes, and they are called radiuses. Now, if you look at the diameter, as it turns out, there are in fact 2 radiuses, one radius there and one radius there, which tells us that the diameter is equal to 2 times the radius. Ka-ching, thank you very much. Now, obviously, those who understand the content will be brilliant at this type of thing, but unfortunately, with circumference, there were some curveballs thrown and tricks that sort of tested your understanding rather than whether you were going to regurgitate the information. And this question was a prime trick for circumference, and we sort of use the same trick with circles. Now, the circumference of a circle is 2 pi r. Now, that's the circumference of a whole circle. And basically, when it was asking you to find the perimeter of this shape, there was a huge trick. Because yes, you have half a circle there. So the idea is you do, in fact, use the circumference and you find the circumference of the whole circle. Okay? Now, lots of people didn't know that, but you guys do. If I wanted to find then half of that circle, I would effectively do my whole circle and divide it by 2. But here was the trick. When you take a whole circle and you divide it by 2, you're actually only getting half of the circumference. If I now look at this shape, all that distance I'm about to find out is that distance there. But perimeter is the distance you walk all the way around the shape. So if I start here and go around half my circle, well then yes, that's half my circumference, but then I have to go back that additional 25 centimeters. So I would then have to add on the 25 to give me my correct answer. Huge trick with circumferences, all right? And again, it tests whether you understand or whether you regurgitate. Now, what is the space inside? Well, inside my head, there's not a lot there's not a lot at this moment in time. But if we look at the space inside that shape, the space inside this shape, the space inside that shape, or in fact the space inside that shape, it is the area. So obviously area is the space inside shapes, and you would be able to find the area of all of these. This is a square, and you would know that the value of area is L times L. Why? Well, because you've got a square or a quadrilateral, it's base times height, and off you go. Same here, the area would be L times W, or length times width. What about the area of triangles? Well, we know that. We've got a formula, half times base times height. And you've got to remember that your base and your height are connected by that right angle. So I tend to think of it as my right angle having two arrows there pointing to the side saying, choose me, I'm the height, I'm the base, choose me. I know. Likewise, for the area of this shape here, it's absolutely base times height. It's just like a quadrilateral that's been pushed over. And so long as these two sides here are parallel, the area is exactly the same as it is a rectangle, for example, base times height. We moved on to more complicated shapes, and we call them composite shapes. We're coming out to them in a moment. All right, and here is an example of a composite shape, probably a more complicated example, but how would you find the area of this shape here? Well, I can see 2 shapes there. I can see a rectangle and above it I can see, or on top of it, I can see a triangle. Now if it were me, I would find the area of the rectangle, I would find the area of the triangle, and I would subtract them from each other. Why? Well, because we've cut out the area of this triangle. So when we cut it out of a shape, we would have to subtract it. How would we do that? Well, we would know the area of our rectangle was 10 by 6, which is 60. Can we find the area of my triangle? Well, we know that that height was 4, and we knew the base was 10. So again, that would be a half times 10 times 4, which would be a half of 40, or 20. And then obviously, what would I do? I would subtract them, because yes, that 60 minus that 20 would give me the area of my composite shape. So the area of that would equal 60 minus 20, or 40, and units are critically important, meters squared. So I should have written meters squared and meters squared there, because you're going to get marks deducted from you in an exam if you don't put units. So what is the space inside a circle? Well, as it says there, there are 1, 2, 3, 4, 5 different ways of writing this formula, and I can guarantee you, as maths teachers, we will choose the trickiest one for you, but it doesn't matter, because you're just going to know it's a trick. This is one way of writing it, pi. We met pi in the previous video, remember? Times radius squared. Yes, radius squared. What on earth is radius squared? Well, if you remember, 2 squared is the same as 2 times 2. 3 squared is 3 times 3. 5 squared is 5 times 5. And so anything with that floaty 2 basically means multiply it by itself. And to go down this, what do we see here? Another one of these ways of writing is pi times radius times radius. Okay, now if we backtrack up, we can write that simpler as pi times r. And as I've just said there, r times r is exactly the same as r squared, which leads us to this formula here. Now, that's no different from the one written in that circle, but the circle is just more visual for you. The formula that I'm putting a box around now is the one that most people remember. Area is equal pi r squared. Pi times radius times radius. And that's what we're going to use for this whole lesson. All right, finding the area inside the circle. Here are some examples. Use your calculator to find the area of this circle correct to 2 decimal places. Okay, area is equal to pi times radius squared. Formula, substitute, solve. So formula, 1 mark. Substitute, 1 mark. Solve, probably a mark. So area is equal to pi times 2. Now I can either write it as 2 times 2, just to remember, or I can write it as 2 squared. My calculator can do that for me. So how are we going to use my calculator? Well, first things first is we need to make sure that we know that the pi button is there under Math 1. That's if you're using the Casio ClassPad. Otherwise, I'm sure you'll find it's normally a button on more basic calculators, all on its very own somewhere towards the bottom of the calculator. So loading up my calculator, there we go. What am I going to do? I'm going to scroll back up to the question just to remind myself, and it's going to be pi times, for some reason my calculator doesn't want to go, pi times 2, and there's lots of ways of doing squared. There's a squared button for you there that you can click, or I'll show you a different way for a different question. But there we go. Area of that circle is equal to 12.57 centimeters and squared. Now if you watch my circumference video, remember, circumference is just a length, it has no floaty units. Here, centimeters squared, area has always got squared units. Really, really important. Okay. Now there will be questions, as I say here, where you have to approximate the area. And again, building on my last video, if you remember, there was pi could be approximately 3, pi could be approximately 3.14 or 3.142, or 22 over 7. Now these aren't exact values of pi, they are approximations, and we tend to throw those in to more test your working out than your ability to find the area. Seems a bit unkind, yes? So the question will let you know which approximation to use. Let's find the area of this question here, and let's use an approximation of 3. So if I use pi is approximately 3, then area is going to be pi times radius squared, formula. Area is equal to pi times radius squared, which is 2 squared. Oh, hold on a moment. It's told me to use my value of pi as 3. So that's going to become 3 times. Well, what does that become equal to? Now, when you do this type of stuff, you have to make sure you do BIDMAS. And that says brackets, indices first. So you have to do that floating number first. So that becomes 3 times 2 times 2 is 4. And so area becomes equal to 12, in this situation, centimeters squared. Easy peasy, lemon squeezy. What about if they told me to use pi to be approximately 3.14. Doesn't matter. Pi times radius squared, which is equal to 3.14 times 2 squared, which is 3.14 times 4. And again, you don't have to, go for your calculator here. You just do short division, whatever, long division, whatever you need to do. So 4 times 4 is 16, 4 times 1 is 4, plus 1 is 5, 3 times 4 is 12. So there we go, that becomes 12.56 centimeters squared. And we can keep doing this with all the other approximations, but basically it's just testing your working out. Here are examples then where we got 22 on 7, because people hate fractions, don't they? So our area is equal to pi times my radius squared. 22 on 7 times my radius squared, which is 7 squared. All right, so let's do some working out. That's going to give me 22 on 7 times, well, 7 squared is 49, which I can write as 49 over 1. Why am I doing this? Well, again, go back to my videos on fractions. It'll show you wonderful ways of cross-cancelling. Now, because I've got a number on the bottom and a number on the top that is both divisible by 7, 7 goes into that once, 7 goes into that 7. And so what do I get? 22 times 7 on 1 times 1. Well, that's 1, and so I can effectively just disregard it because we don't need to write it. Oh my goodness, how am I going to do 22 times 7? A side calculation. Yes, that's what I thought. 2 7s are 14, 2 7s are 14, and that gives me 154 centimeters squared. Oh no, not centimeters, meters in this situation. See, don't get tricked, always look at the meters. Let's zoom in. So I've got this one. What about pi? As 3.14, exactly the same. So let's formula, area equals pi times radius squared, which is 3.14 in this situation, times 10 squared. What's 10 squared? 10 times 10? 100, I can do that one. 3.14 times 100. Oh, thank you, because they've given me a place value question. When I multiply by 100, just move the decimal point by 2 places. So that becomes 314. My units are centimeters, and I have squared. So all of this is just repetitive. Now, as I say here, zooming back in just a little bit, area is pi r squared, but that is the area of the whole circle. This is where we start to throw in the tricks. So the question is, how would you find the area of that section? Well, hopefully all of you are looking at that and know instantly, hold on a moment, that's a quarter. Of course it's a quarter, yes? How do we know that? We've got that right angle there. But there is another way of working it out, which is sort of leading into my next video. So if I look at the number of degrees, I've got 90 degrees out of how much of a circle? Well, there are 360 degrees in a circle. And if I was to put that into my calculator, and I know all of you already know this, but I'm just showing, if I do 90 divided by 360, put my calculator in standard mode and hit enter, OMG, it's a quarter. So I can actually look at the number of degrees they've given me and divide it by 360 to find some sort of fraction of the circle that I've got. So if I know the area of a whole circle, and notice I put an O there, that just means whole circle, is equal to pi times radius squared. Do I know the radius? I should cocoa. The radius in this situation is 3 meters. So I get pi times 3 squared, which is pi times 9. Now that's my whole circle. So let's carry on over here. Area of my whole circle then is equal to 9 times pi, which gives me, take it out of standard mode, put it back into decimal mode, thank you very much, gives me 28.27 meters cubed. Now actually, that's not my final answer. Now, so while I've rounded it to 2 decimal places there, I'm actually going to use all those values that you can see in my calculator. So did I want the area of the whole circle? No, I didn't. I want the area of that quarter. So that's now going to give me a quarter times the area of my whole circle, which is a quarter times 28 point, what did my calculator say? 274 ... And I always use the ... to show my teacher and my examiner that I've got more points here, I've got more decimal places, and I'm being clever. So I'm going to multiply that by 1 divided by 4, and that's going to give me 7.07 meters squared. That is my final answer. Find the area of the following. Don't be tricked by the same trick. Now, obviously, once people have seemingly thought about this as a circumference, they get mad then. They just keep adding on 5 kilometers everywhere. You don't. This isn't circumference anymore, right? So in this situation, we have the area of how much of a circle It's half a circle, absolutely. So find the area of the whole circle, pi times radius squared, which is pi times phi squared. No, it isn't. See, if you thought it was phi squared, don't forget it isn't. That is my diameter. So if my diameter is 5, my radius is half of that, or 2.5 kilometers. That is one big circle, by the way. So 2.5 and squared. So what does it say? We can use pi button on my calculator. So pi times, and I'm going to put this in brackets, 2.5. Oh, no, I'm not apparently. I'm going to do 2.5, and there's the other way of doing it. See, I can just put that little caret and a 2, that's the same as squared. Hit enter, and out comes 19.63 kilometers squared. That's my final answer, yeah? Nope. Why? Because that was the area of the whole circle. How do I find the area of half a circle? Well, funnily enough, I'm going to half the value I've just got. Half times 19.6349 dot dot dot, which gives me, so I'm just going to multiply that by 1 divided by 2, and then I have 9.82 kilometers squared. Whoa! These questions here are probably one of the most important and popular types of exam questions over and over again. They're composite shapes. Right, so going back to the almost beginning of this video, then what do? Well, we can see that to be able to do this. I'm going to find the area of what is effectively a square. I'm going to find the area of the circle, and then I'm going to subtract them, because we're going to assume that this is the area we want to find. So they've taken some sort of square piece of material and they've drilled a hole through it. So how do we find the area of the square? So area of square is going to be 10 times 10, which is 100 centimeters square. That's nice and easy. How do we find the area of the circle? Well, the area of the circle is going to be pi times radius, not 5, 2.5 squared, which gives me, now funny enough, I've already got that on my calculator. So area times 2.5 squared was 19.634. Scroll this over, centimeters squared. And what are we going to do with them now? We are absolutely going to subtract them. So therefore, the area of my composite shape is equal to 100 minus 19.6349 dot 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 dot, which gives me, so I'm going to do 100 minus, and because these calculators are awesome, I can highlight, drag and drop, and that's going to give me an answer of 80.37 centimeters squared to 2 decimal places. Now this is the last part of this video, okay, and we're going to do it backwards, because sometimes they're going to give you the area and expect you to do this backwards. How do we do that? Right, well, here we go. Here's the radius. So it says find the radius of a circle when the area is equal to 50 centimeters squared. Always write your formula, pi times r squared. Formula, substitute, solve. So formula, substitute. Told me the area is 50, write 50 underneath. Pi, we know what it is. R is what we're going to try and find. Okay, so first things first, I'm going to get rid of a times by pi by dividing both sides by pi. 50 divided by pi is equal to r squared. And then I may as well finish this off, because I know how to get rid of a squared. I square root both sides. Now, if you're not sure what I've done there, that's patterns in algebra. There are sections on my website that will allow you to see all of this type of craziness and apply it to this type of stuff. But this is really important in maths. The further you go through in maths, the more algebra you're going to use. Can I put that into my calculator? I can. There's my square root sign. There is my fraction sign. So if I do 50 divided by and pi, ooh, where's my pi button gone there? Not root pi. Let's just do pi, if you will. So putting that into my calculator, square root and fraction button, I'm going to do 50 divided by pi, not pi, hit my button, and there we go, we get the radius is equal to 3.99, I assume, centimeters. Why is it centimeters? Because the question was given in centimeters. Now, yes, those of you who are using a CAS calculator may well know that you can use the solve function. So I could actually have taken this line here and said, let's solve it. Showing you how to do that, we got solve. So we have solve. I don't know what's going on with my calculator, there's a strange lag. Solve, and I type it exactly as it is there. 50 is equal to pi times. Now I never use r because my calculator has the letters x, y, and z easy for me. So I'm going to say, well, let's pretend r is x squared. So there's my formula. I do a comma and I put in to say, can you solve for the value of x? and outcomes, and this is where using a solve function gets really, because your calculator is nothing more than a dumb piece of machinery. I mean, it's probably too clever for you in this situation, but basically it's turning around and saying, well, the radius has actually got two values, 3.99 centimeters and minus 3.99 centimeters. And in this situation, you're going to look at that and go, hold on a moment, I can't have a negative radius. Now, there are reasons for this, and it's all dealt with in another video. This video is long enough, so maybe you need to go and find a video on positive and negative and square roots. Otherwise, we can use our solve function and interpret the result as 3.99 centimeters. There we go, ladies and gentlemen. I'm done. And there we go, we are at the end of area of a circle. Thank you very much for watching. If you haven't already done so, can you subscribe? Remember, there's about 8 people watching these videos, and if you click that button, it lets me know that there are 9, and I would be deeply, deeply grateful. If not, hopefully I'll see you in another video. You take care of yourself, yeah? This is MaffsGuru signing out. Stay safe. Bye-bye.